So are you ready to put that inverse square law into a practical situation? I've got my model Isabel here today, and we're going to show you flash to subject distance. Now, using the inverse square law, I've started her out about a foot away from the softbox. So we'll take our first shot here. I am at f8 at 160th of a second, and she's perfectly exposed. But again, with the inverse square law, what you're going to notice as at 1 foot away, if we were now to move her back another foot, double that distance, what we'll find is that, let's have you step back about 1 foot. So right there, if I take the same shot without changing any settings, I doubled the distance, so I lost 2 stops of light. So now she's 2 stops underexposed. So what I'm going to need to do is I'm going to need to open my lens up. I'm at f8. I am going to take it to f4. So that is 2 stops that I've opened my lens up. And now, at f4, I have the same exposure that I had at f8 because I moved her double the distance from the light source. Now, if I double that distance again, not double the initial, but double where she's at now, if she is now at 2 feet away or 3 feet away, let's move her 3 feet back, so let's come back to about here. We've doubled the distance once more, and if I take this shot at f4, we're going to find that now, once again, she's 2 stops underexposed. The way I'm going to compensate that is I'm just going to open my lens up 2 stops, so from f4 to f2, and take that exact same shot. I am going to find that I have that same exposure that I had at f8 and that I also had at f4, now at f2. So one of the things I want to do, what I want you to see though, is this area that I start losing those 2 stops of light start getting wider. So now between 3 feet and 6 feet, I lost 2 stops of light. Now I won't lose 2 stops of light until I'm 6 more feet behind Isabel. That's where it starts to get very interesting, because if I had a group, you would find that if I had everyone up here back where I started at with her, the person in the front would be perfectly exposed, but the person standing behind her would be up to 2 stops underexposed. So the way we use the inverse square law is if we're shooting a group, we move them further away so that we have wider areas of consistent light. So if I was shooting a group of her friends with her, I would move them about 6 feet back, because now I know if I put 2 rows of friends in there, they're going to only be about a 1/4 of a stop difference between the front and the back rather than a 2-stop difference. So you can use it for your advantage when you're shooting with groups. The other thing is, by moving her closer, if I had her against the wall and I wanted to darken the background, I actually would move the light closer to her, which would in turn make the light fall off faster, so it would get darker much quicker. If I wanted to darken the background, it sounds counterintuitive, I would actually move the light closer. So that's how you use the inverse square law and your flash to subject distance. If I were to meter 2 feet away from my light source, it would require my camera to be set at f22 in order to be properly exposed at that distance. If I doubled the distance to 4 feet, I would lose 2 stops of light. My camera would now need to be set at f11 to be exposed properly. Let's double it again to 8 feet, and now our camera would need to be set at 5.6. Again, 2 stops less than it was at 4 feet. What I want you to notice is the distance between the stops of light is getting larger. Let's bring in our band and try to expose the group correctly at 2 feet from our light source. What we notice right away is the person in the front is properly exposed, but the person in the back is underexposed by more than 2 stops. One way we could try to fix that is just to scrunch everybody up. This tends to make people feel a little uncomfortable and a little awkward. Knowing what we know about the inverse square law, would it not be easier just to move them back where the light may be less, but the distance between stops is greater? Notice, in the final shot, there's less than a 1/2 a stop difference between the closest band member and the furthest.